Hello and welcome to part 7 of the demonstration of segment routing. In the previous video, we had shown how we could load balance traffic over non-ECMP paths by creating this tunnel, which required a fairly long tunnel definition, but on the wire, it actually reduced to just a couple of labels. But we could always come across a case where the tunnel definition ends up requiring a very deep label stack. For example, this particular tunnel actually requires a label stack that is 4 or 5 labels deep. Now, a deep label stack can cause a problem in some hardware switches where we cannot push more than 3 labels. But where there is a limit on how many labels that we can push. For example, maybe the limit is just 3 labels. But this is also a perfect example of the power of SDN, where we can use software to get around the limitations of hardware. And so in this video, we will show a feature that we call segment stitching, whereby parts of a deep label stack can be stitched together in the network, and the controller takes care of doing all the stitching for the network operator. So let's go ahead and start by creating the tunnel that is shown in the picture. We'll call it tunnel TCR, and we start at node 107 and choose one of the outgoing ports by using the adjacency label for that port. The tunnel continues in node 108, followed by node 102, and then continues on at node 103, and then at node 104, finally to node 105, and the tunnel ends in node 106. So by looking at this tunnel, we see that the tunnel path we created is very long, and it reduced to a label stack which is 4 labels deep. But notice something special about this label stack. It actually shows up as 2 different label stacks. The first one, which pushes 3 labels, 102, 103, and 104, and the second one that pushes a single label, 106. So if we take a closer look at the details, we now find that there are 2 different groups in 2 different switches that represent the same tunnel. The first label stack is pushed in the first switch, which is the head-end router, and the second part of the label stack is pushed in a router that is further inside the network. So looking at the originating router or the head-end router, we can see that group 23, as expected, is a start of a chain that pushes the 3 labels, 102, 103, and 104. And if we look, this label stack will result in a naked IP packet reaching router 104, which is certainly not the destination router. So in router 104, if we look at group 10, which was also created as part of this tunnel, in group 10, there's a single bucket and a single chain, which essentially pushes the last label, 106. So again, no traffic is actually going down this segment stitched tunnel until we actually create a policy. And so the policy that we'll create is just the same as the policy that we created in the previous video, but we'll, for communication between the 10204 and the 10202 subnets, but we will give it a higher priority, so the traffic is diverted into this tunnel, which is the tunnel that we just created, tunnel TCR. And with that, we can look at the tunnels. We can see that the new policy that we created is taking the the segment stitch tunnel, we can also show policy to make sure that the policy is taking the right tunnel. But what's more important is that if we go and look at the ACL tables where the policies are actually implemented, we can see that in the origination router or the head-end router, the ACL table definitely shows that priority, definitely shows the policy that is classifying packets. But also down the road in switch 104, we take a look at the ACL table in that router, and we see the same policy also classifying the same set of packets. So in this way, the operator can create label stacks of any size, and the controller takes care of doing the stitching at the necessary stitch points in the network.